Hello, this is Professor Kuehn, and today I'm going to work through a solution to another one of the problems that I assigned for my AP Physics course. This is a problem in which two masses are suspended from the opposite sides of a pulley, and you're asked to find information about the acceleration of these masses, the angular acceleration of the pulley, and so on. So let me sketch the situation. This is very similar to the previous problem we worked out in that you have a disk like this, and the diameter of the disk is 5 centimeters. I'm just going to indicate the radius by r. The radius, again, is 2.5 centimeters. And now you have a mass suspended from this side. This is a 10 kilogram mass. I'll call this mass 1 that's suspended from this side. This is 10 kilograms. And you have another mass suspended from this side. I'll call this mass 2. And then I'll call m the mass of the pulley. And I think I give you the numbers for these. I think this is 10 kilograms. The pulley is, I think, 2 kilograms. And mass 2, I think, is 3 kilograms. And the idea is that you want to find out what the acceleration of each of these masses is and the angular acceleration of the pulley. So what we're going to need to do is we're going to need to employ Newton's law, second law of motion 3 different times and then connect the equations. Okay, so what do I mean by that? Well, the first mass, m1, well, it has, I can represent it using a free body diagram with a weight like this. I'll call it weight 1 is downward. And then there's a tension in the string that is trying to support it. I'll call that T1. And what's going to happen is, since mass 1, you can probably see what's going to happen. Since mass 1 is larger than mass 2, it's going to accelerate downward. That is, the weight is going to be bigger than the tension, and hence there's going to be an acceleration of mass 1 in that direction. Let's call that direction the positive direction. If it accelerates downward, we'll call that a positive acceleration. Okay? What about the other mass? Well, we'll draw a free body diagram for this one as well. We'll have its weight pointing down like this, weight 2. There's another tension right here, and let's denote this by T2, tension 2. It's important to note that this tension is not necessarily the same as tension 1, okay? And its acceleration, you might see the acceleration as m1 falls, m2 is going to go up, so this one is going to have an acceleration upward, like this. I'll call that acceleration of 2. And let's just, for the sake of argument, let's call the positive direction of this one downward. So what we're going to find is acceleration 2 is going to be in the negative direction. Okay, so positive is downward here, positive is downward there, and we're going to find a1 is going to be a positive number, and a2 is then going to be a negative number. Okay, so we're going to have these two equations of motion, and then finally we're going to have an equation of motion for the rotation of the pulley, and we can say that the net torque on this is equal to its rotational inertia times its angular acceleration. Let's call positive angular acceleration in the clockwise direction, positive alpha in that direction. Okay, so far I've sketched these. Let's go ahead and write down these equations. So let's start with this final one, the torque equation. The sum of all the torques acting on this pulley is equal to its rotational inertia times its angular acceleration. What are these torques? Well, you've got a tension, T1, pulling down like this. Of course, if T1 is the tension pulling up on this mass, by Newton's third law, that same tension must be pulling down on this edge of the pulley like that. So T1 times R. I'm going to make this positive because it's a positive torque. It's trying to make it rotate in the clockwise direction. Now we've also got another torque that's trying to make it rotate in the counterclockwise direction. So let's make this negative. I'll call this negative T2 times R. So those are the two torques. That's the sum of the torques acting on this pulley. And that's equal to its rotational inertia, which I'll go ahead and write down 1/2 mr squared, because I know the rotational inertia of a disk is 1/2 mr squared times alpha. Okay, so this is our first equation that we're going to need to use. The second equation is going to be from Newton's second law applied to this mass, and the third equation is from Newton's second law applied to this mass. So let's go ahead and do this one. We'll say that the weight, W1, minus tension 1 is equal to mass 1 times the acceleration of mass 1. Again, I'm taking positive to be downward. And then our third equation is applied to this mass over here. We'll call it weight 2 minus tension 2 equals mass 2 times acceleration 2. Okay, and again, I'm taking the positive direction to be downward. And again, a reminder is that we're going to find out that this acceleration, since it's upward, we're going to have a negative number for that acceleration. Okay, now what are we going to do? We have to connect these three equations. So what we're going to do is we're going to solve equation 2 for the tension, and we're going to plug that in up here. We're going to solve equation 3 for the tension, and we'll have to plug that in up here. And then we also know that this acceleration and that acceleration and the angular acceleration are going to be related to each other. So we're going to have to somehow connect those. All right, so let's continue down here. So let's first solve for tension 1. Tension 1, you can probably see, is going to be equal to weight 1 minus m1a1. So I'm going to write this, let me denote some space or carve out some space right here. So weight 1 minus m1a1, that's tension 1 times r, minus, again, I'm plugging all the stuff into equation 1 right away. Tension 2 is going to be weight 2 minus m2a2 times r, and that's going to be equal to 1/2 mr squared times alpha. Okay, so this is plugging equations 2 and 3 into equation 1. Okay, now let's plug in some other stuff here. We know weight 1 is m1 times g. So what I'm going to do is I'm going to plug that in, m1 times g, and I'm going to factor out r right away. So I have g minus a1 minus, well, weight 2 is m2 times g, so I'm going to factor out an m2 times this r right here, and I'll have g minus a2, and then over here I have still 1/2 mr squared times alpha. Okay, so again, this first term m1rg comes from the weight, and the second term m1r times a1, it comes from this term right here, and so on. Okay, I know the masses, I know r, I know g. I don't know a1 or a2 or alpha, but I do know that those are connected to one another. So let's think about that. Okay, so what do we mean by a1? We mean the acceleration of object 1 as it goes down. That's going to be related to the angular acceleration of this pulley, so that'd be alpha. So a1 is alpha times r. What about a2? Well, you might say a2 also is equal to alpha times r, but we have to be a little bit careful, because when alpha is positive, a2 is going to be negative. So we're going to have to put a minus sign right here. So negative a2 is going to be equal to alpha times r. That way, when this is a positive number right here, this one will be a negative number. Okay, so now what I'm going to do is I'm going to go ahead and plug in these values for the a's in terms of alpha. Then I'll have everything in terms of alpha. So let's do that. So I'm going to write this as m1 times r times g minus alpha r minus m2 times r times g plus alpha r equals 1/2 mr squared times alpha. Okay, now what I want to do is I want to solve for alpha, so I want to get everything with an alpha on one side. So I'm going to keep the m1 times r times g on this side, that's the first term, and minus m2 times r times g on this side. On this side, I'm going to have 1/2 mr squared alpha, and I'm going to want to move this m1r times alpha r over to this side. It's negative over here, so it's going to become positive over here. So m1 times r squared times alpha. And then here, I've got negative times positive. So this term is going to be negative. I'll move it over here, and I'll have 1/2 m2 times r squared times alpha. Okay, hopefully I've gotten all my signs correct. Now I'm going to factor out the alpha. And by the way, notice that I've got a factor of r here, a factor of r here, and 2 factors of r each over here. So I'm going to cancel out one of these factors of r in each of those, and I'm going to factor out the alpha. So I'll have 1/2 mr like this, plus m1r plus m2r, and that is going to be equal to g times m1 minus m2. Okay, all right, now I'm going to have to move up to here, and I'm going to solve for alpha. And by the way, I might factor out the r's from each of these in the process, but it'll go like this. Alpha is equal to g times m1 minus m2 divided by this whole thing that's in parentheses. I'm going to factor out an r right here, and I'll have 1/2 m. Did I forget something? Oh, here's my problem. All right, let me go back. I forgot both r's right here. So m1r, this should be an r, let me see, r 1/2. These are r squared, that's right. All right, I'm going to keep going. Assume I got it right. 1/2 mr, I don't think I got it right. Plus m1 plus, I bet I did, m2, like that. All right, and then I can say that the angular acceleration is g over r times this factor, m1 minus m2, I got this right, times 1/2 m plus m1 plus m2. Okay? All right, so notice what's happening here is that I can now plug in my masses and figure out what the angular acceleration of this guy is right here. Notice that because m1 is bigger than m2, this is a positive number. All these are positive. G is positive, r is positive, and so alpha is positive. It's going to undergo a clockwise angular acceleration. Okay? And furthermore, notice that if I multiply both sides of this by r, I can get the acceleration of mass 1 and the acceleration of mass 2. So I can say acceleration of mass 1 is going to be equal to g times m1 minus m2 over this factor 1/2 m plus m1 plus m2. And acceleration of mass 2 is going to be the same thing but with a minus sign. So I'll call it negative g times m1 minus m2 over 1/2 m1 plus m2. Oops, 1/2 m plus m1 plus m2. I'll erase that just so it's not confusing. Oops. M plus m1 plus m2. So notice that when you plug in these masses, a1 is going to be a positive value and a2 is going to be a negative value. As I said before, this one's going to be accelerating down, this one's going to be accelerating up. Okay, I'm not going to plug in the numbers. You can do that on your own, but this is the way that you solve this problem. Best wishes, and I'll talk to you next time.